Back in the 20s, we had a triumphing theory that described many things in the universe with large precision, but found trouble with fundamental particles, the tiny ones. Then we also had a sort of strange theory that described all the tiny things in the universe, but didn't conquer with some relativistic conjectures. Well, boy, you can have it all. Unless...
Dirac equation.
Do you know what antimatter is? Well, you don't have to yet. Only know that its discovery was elegant and revolutionary. This may be the first time where, only using math, someone predicted a new set of particles. That's sweet! But how? Well, let's see how. We're gonna assign a famous equation to the theories I mentioned. So we have quantum mechanics theory and special theory of relativity.
The mass-energy equation goes to special theory of relativity, and Schrodinger's equation goes to quantum mechanics.
We're ready. The mass-energy equation says that mass and energy are somehow the same thing. In other words, if you could take pizza and accelerate it to the speed of light, which is a really large speed, actually the fastest you can possibly go, you will transform the pizza into a lot of energy. And also, if you have a lot of energy, you could transform it back into matter. Anything. Pizza again if you want. Oh, that sounds nice, I'm gonna get some. But we need to make a few fixes to this equation. We're gonna work with some really small things. And there's one without mass, but with energy. The photon. So, if we substitute the mass of the photon in this equation, it won't work. Then let's use this one, with P meaning the momentum, where it totally works, even with photons. Now let's see Schrodinger's equation. It describes the probability of 1, 2, or even entire systems of electrons and protons to be in a determined quantum state, with defined properties. Imagine you put pizza in the oven and don't know its ingredients or properties. Schrodinger's equation, or in this case, Schrodinger's pizza oven, tells you how likely you are to get a pepperoni or a cheese one, meaning energy, angular momentum, and so on with particles. Remember, theory of relativity had trouble describing these particles. I mean, if you have something big, you can locate it every time. That's why it's hard to lose your car or your house. But once you go smaller, it's more difficult to locate something, like your keys. In this case, we can always tell where a planet or a star is, but it's impossible to say precisely where a particle is. They're really small. That's why we need probability. Okay, so now we can go further. Dirac took these two, made a few mathematical, mother of God, a few mathematical fixes relating space and time, like relativity said, but still describing a quantum system. So Dirac equation is quantum and relativistic. But look, this has a quadratic equation. That means that it has two possible answers, a positive one and a negative one, like the square root of 9, where 3 and -3 are both valid. What is this?
Antiparticle!
Oh, antiparticles. Only using math. This means that from every particle there's an antiparticle with exact same properties, but opposite charges. Anti-electrons called positrons, antiprotons made of anti-quarks, etc. So if we transform a lot of energy into pizza, theoretically we will have also an anti-pizza made of anti-elements and antiparticles. So it's a double portion of pizza! Well, not so fast. If I eat the anti-pizza, I will explode and die, since matter and antimatter explode when they are together, and I am made of matter. Also, since elements are made of particles, we could have anti-elements, and well, the universe is made of elements, so there may be an anti-universe. In conclusion, if there's an anti-Dirac equation, it surely is made of anti-brilliant ideas.